this on. Oh, it's in the wrong place. Yeah, let's see if I can make it bigger. Doesn't work. All right. So we're still doing factor and trinomials. We are just looking at a couple of special cases today. So the first one we've done before, and this is just called the difference of squares. You don't need to remember that's the name, but it is, in case someone asks. This is only true if both of your terms are perfect squares and there is no middle term and they're being subtracted, hence the name difference of squares. So if that's the case, our rule is we have a squared minus b squared. Then when we factor it, we're going to have a minus b times a plus b. Okay? So all we need to do is we need to take the square root of both sides to get a and b. So in this case, 25x squared, we have a equals 5x. The square root of 4 is 2, so b is 2. So our factors would look like 5x minus 2 times 5x plus 2. There's our answer, and you're all finished. You don't have to do anything complicated. You don't have to worry about finding the factors and then refactor and factoring again all the steps. That's it. That's the whole thing. Okay, this only works. You're missing the middle term. You're subtracting, and both the terms you have are perfect squares. So it's kind of particular, but if you're in a math class, you'll probably see it because they want to see if you know this rule. All right, our second one. We're going to look at this one two ways. So this is like what we've been doing all week. So we're going to answer it like we've been doing all week. Why not? So you said take the first and last term, multiply them together. It's not blue, but whatever. So 16 times 1 is 16. And then we think, what two numbers can I multiply together that will give me 16, but also add up to negative 8? So I'm going to assume we know how to do this already. And I'm going to say, well, 4 times 4 is 16, and negative 4 plus negative 4 is negative 8. So I'm going to use that as my factors. So something should stand out, but this is the first time we've done this where both factors are exactly the same. And that's your tip-off that something is different. Okay, I'm going to keep going. I'm going to write out my rest. So 16x squared minus 4x plus 1. Okay. So now I want to factor out my first two terms, my last two terms. So 16x squared and negative 4x, they have a 4x in common. So I'm going to factor that out. It's going to leave me with 4x. And then 4x divided by 4x is just negative 1. Okay. I come over to the other side. And I know I want 4x minus 1 in my parentheses to make this work. Because I know this has to be it, because I can't switch the order around. I get the same thing. So this has to be what I'm looking at. So 4x minus 1. So really all I did was I changed the sign. So I'm just going to just have a minus 1 out here. And then that's the second thing you should notice. But wait a minute. What I have on the outside of the parentheses, 4x minus 1, is the same as what I had inside my parentheses. So my answer is 4x minus 1 times 4x minus 1, or more simply, 4x minus 1 squared. So this is different. We haven't seen this before, where both of our factors are exactly the same. So this has a special name. We're going to put that on our next page. Look, it's the same problem. This is called a perfect square trinomial. Again, you don't need to know the name. And if you're happy doing it the way we've been doing, you can sort of just tune out now, because this will get you the right answer every time. But there's a couple of rules for these. Let's say a squared plus 2ab plus b squared, and that equals a plus b squared. Or similarly, but not quite, a squared minus 2ab plus b squared equals a minus b squared. Okay, so this works if and only if you can take, or the first and last terms are perfect squares, so 16 and 1 is good, right? 4 times 4 is 16, 1 times 1 is 1. And then that middle term needs to be that square root, right? Times them by each other. So in this case, we would say 16x squared. So a would be 4, or 4x rather. And b would be, the square root of 1 is 1. So 2 times ab would be 2 times 4x times 1, right? So 2 times 4x is 8x. 8x times 1 is 8x. So 2ab equals 8x. Let me check that out. Does that match? Yes, it does. Okay. If that's the case, if I can square root first and last terms, and then if I can take those two square roots, multiply by each other, then multiply by 2, and get the middle term, then this rule will work. And to give you a hint on the paper we're doing today, it's going to work. And if that's the case, you can apply one of these two formulas. Your answer is either going to be a plus b squared or a minus b squared. And the only difference is whether or not your sign in front of b is positive or negative. So if it's minus there, it's going to be a minus b squared, which is what we had for answer here, right? 4x minus 1. If we switch this around, if we took the exact same expression, only instead of minus 8x, if we put plus 8x, all of a sudden our answer would just be 4x plus 1 squared. I didn't have to do any work, right? Because I already knew. So so one of these formulas will work, assuming this is true, right? And then you just need to remember, because you don't want to make a silly mistake, that whatever the sign is for b, let me delete all that, go back to the original problem, whatever that sign is for b is going to be the sign in your final factor. Okay, so give these a try. Again, if you're like, Ellis, I'm not here to learn new stuff. I was good with the old way. I'm okay with doing the work. That's fine. But we're just showing you there are special cases where you don't have to do all the individual steps. So give them a try. Let me know how it goes. All right. Bye.